Hello, my name is Ken Edwards. I'm an owner and engineer with Elemento Engineering, Research and Software here in Athens, Ohio, USA. And today I am conducting an experiment of water flowing through a horizontal 4-foot test section of plastic tubing. I'm going to measure the pressure drop through that horizontal tubing and the flow rate through the system. So water begins in this tank and flows through a submersible pump through some clear plastic tubing to a valve, and then the water enters our test section, which is PVC 3/4 inch nominal diameter, which is 0.824 actual inside diameter, 0.824 inches actual inside diameter. And we'll measure the pressure at the upstream section of the 4-foot section. Then water flows through the plastic white tubing 4 feet down to the downstream manometer where we'll get a pressure reading. And then the water continues through the clear tubing and discharges freely back into the tank. So the first thing we'll do is measure the pressure in the upstream manometer, followed by the downstream manometer pressure, and then we'll measure the flow rate through the system. The water is flowing steadily through the system. So at our upstream manometer right here, we have a measuring stick in 1-inch increments. 1, 2, 3, 4, and these are inches above the horizontal pipe that is our test section. So then we have water is in this clear tubing, and we have an interface between water and air, which is indicated by the black float, which hopefully you can see in the video. The top of the black float is at the water-air interface, and it's an indication of our water pressure in the horizontal tubing. And so we have a water pressure, or actually more accurately precisely a head reading of about 32.5 inches of water, maybe a little more than that, 32.5, 32.75. It's fluctuating. Looks like it averages at about 32 5/8 inches, which is 32.625 inches, plus or minus about 1/8 inch. So 32.625 inches in our upstream manometer. Now if we go to the downstream manometer, this again gives us a pressure reading at 4 feet downstream in our test section. And at the water-air interface, indicated by the top of the black float, our water level is at about right here, which is about, well, it's fluctuating, but about 30 1/8 inch, or 30.125 inches, plus or minus about 1/8 inch. So then the water flows out of the test section through the clear tubing and then back into the tank. So our next step is to measure the flow rate through the system. And we'll do that by using a bucket that is calibrated in 1/4 gallon increments. These are US gallons. The blue lines are 1/4 gallons. You may also be able to read the text on here, which is 1/2 gallon, 1 gallon, 1.5 gallons, 2 gallons, and so on. So that will help us determine the volume to fill the bucket. And then we'll also record using the second hand on the clock the time to fill a certain volume, and that way we can get the flow rate through the system. So we'll start when the second hand gets to the 3. Okay, so our volume is at about 1/2 gallon now, 3/4 gallon, 1 gallon. Our second hand is coming around to the 6, which is at the 15-second mark into our test. And our volume is now at about 1 3/4 gallons, 2 gallons, and we're coming up on 25 seconds into our test. The volume is now 2.5 gallons, and we'll take this up to 3 and get the time reading. 2 3/4 gallon, 3 gallons, and we're at 35 seconds. So we filled 3 gallons in 35 seconds, plus or minus 1 or 2 seconds on our time reading. I encourage you to watch the following video, which will use software and equations to predict the results of this experiment. That concludes our experiment. Thank you for watching.